Hi, section 5.5 VPNv4 BGP. Okay, this is MPLS over DMVPN technology. We call it 25470 DMVPN or MPLS over DMVPN. Configure network so that site 1, 2 and 3 are able to exchange routes and traffic. And these sites should be in the logical VPN using RT100. Okay, site 1, 2 and 3 they have to exchange route and in RT100. Let's see the topology. Okay, this is we have DMVPN, and that R6 is hub, 7 is hub, and 15 and 16 are spokes. This is phase 2 DMVPN. This is phase 2 DMVPN. 15 and 16 are spokes, and 6 and 7 are hubs. This is. We have to implement MPLS over DMVPN. In phase 2, 15 and 16 can reach each other without traversing hubs. And for this reason, we can face problem, and we will see what we will have and explain the problem. Okay, let's see what is the RT. This is $100 with target 100 to target 100. We have with target and with target 100 here. Okay, this is and this is in MPLS. We have blue, green. Okay, this is PE, this one is P, and this one is P. In P devices, we have VPNv4 and address family for VRF that is connected to switch 3. We have we should have address family VRF for on the BGP configuration for both sides here and here. This is BGP. This is special. This BGP link. We should have address VRF address family on the BGP section for this link and this link. For this one, we have 2 other VRF. Then we have to have VRF address family on the BGP section for this one and this one. This is PE, which let's show what I'm saying. The 50, yeah, show run pipe section rotate BGP. This is P. We have VPNv4 address family. We have short VRF. We have VRF hostone and red. It is connected via hostone is. This is 15. Hostone is connected via 214 and 815. 215 and 815. This is hostone and 315 for hostone and red. Okay, this is we have for hostone. This is BGP. I have to add another IPv4 VRF for this red, and on the 16, let's see, show VRF. I have two VRF, customer VRF. One is red, the other one is blue. Show down pipe section rotate BGP. I have VPNv4 address family. I don't have any VRF address family for red and blue. I have to add this VRF address family on the BGP section. One for red and the other for blue. And 12. So we have Reno here. Show down pipe section rotate BGP. I have VPNv4 address family. I have to add IPv4 VRF Reno on the BGP section. Okay, let's connect this with that. This is VRF. I have to have VRF here. I have already have here. I have to add VRF for this one, and for this thing I have to add VRF and this thing. Then after adding VRF, I have to distribute. This is speed. I have to redistribute this VRF protocol, or this we have OSPF. Let's see what we have to redistribute here. On the P 15. Okay, for VRF we have another IP protocol. Show IP protocol. This is global. This show IP. This is for global holding. And for VRF show IP protocol, we have VRF red. Okay, this is IP protocol for VRF. We have OSPF process ID 1550. For VRF, show IP protocol VRF host BGP BGP. Okay, for that shut down path section rotate OSPF. I have to redistribute this OSPF process inside BGP. I have to redistribute OSPF inside BGP. The under OSPF I think we should redistribute this OSPF inside BGP and vice versa, redistribute BGP inside OSPF. Same here. 12 show on path section rotate GRP. Okay, we have rotate ERG start. We know we have to redistribute BGP here and vice versa. Show down pipe section rotate BGP. On the I have to redistribute ERGRP on the VRF address family. This is the same. Redistribute this, and this is the same. This for both ERGRP and both OSPF. And that for the Reno Western on-site blue one are able to bring RT. Reno Western on-site blue one. Site blue one. Okay, this is RT 200. Western RT 200, and then this is RT 200. This is with target 200 on the VRF definition. Okay. Ensure that no routes are exchanged between two logical VPNs. Okay, this is saying that we have to say with target export, with target export and with target import are the same. For example, 2020 or 100 because these two targets should not see each other. Then we have to export 200 and export 200. and export 100 and import 100. But if we want this section, want to see this one, we have to export then import, for example, 100. Okay, export 200. Let's say we have export and import 100 here and here, then import and export 200 here and here. Okay, full HTTP based plannings. Let's configure. Before configure, let's see what MPLS over DMVPN is. This is also called 2547 or DMVPN or DMM. It was MPLS over DMVPN. Let's say provider, I can't. So this is 60 this excellent this is important for DMVPN hubs should be a pre-device to label switching packets between the hub and spokes. In our topology, 6 and 7 are hubs. These are P devices also. Let's verify. In P device we don't have VIF, show VIF, but we have only show pipe from pipe section. We have address family VPNv4 for MPLS for 12. This is for this section. This is not for the VPN. We have P for VPN. Same as 6. Show VIF and show down pipe section. Okay, BGP. We have address from VPNv4. This is P devices. Okay. And then let's make your packet to be switched somewhere between P. You see, you can labels. Running episode of event tunnels makes the remote branches router as a full function P router, which means label impositions is done in branch router and label switching must be performed all the way between spokes. This we have issue here for this reason. This is our issue here. This requirement makes the direct spoke communication impossible due to lack of allocation mechanism and dynamic created spoke tunnels. Okay, this is the issue that we will face, because we have phase 2 DMVPN here, and in phase 2 spokes can connect each other without traversing hubs, but we don't have label for these links because we don't have MPLS labels for links between spokes. We will have problem. And However, label switching between sport can easily be done. Being able relationship the operator label switch package. Okay, so we have to use DMVPN Phase1 design for this deployment where spoke to spoke traffic traverse the hub. Okay, we can fix the problem by another way in DMVPN Phase2. Let's see what can we do. Let's configure. Okay. Let's start by RP. Okay. Show IP protocols. We have ERGRP and BGP here. This is ERGRP. Address family, excuse me, name it mode, host tone, and AS7. So here name it mode. We have to distribute BGP. We have to distribute BGP inside the ERGRP and we distribute ERGRP inside BGP. Show run pipe section with the BGP config T. Okay. Show run pipe section with the ERGRP. Address family. Okay, we have to go into topology base for redistribution. Let's see. We have to use metric. What is link? 3.1. Okay. Do sharp interface brief. Do interface. This is this interface. Do show interface. Okay. Redistribute. We have this BGP 200. We have BGP 200. And to show IP Pro part include BGP. Okay, BGP. We distribute BGP 2000 metric. This is bandwidth. Bandwidth is, where is bandwidth? between 10,000. Delay in tens of microseconds. We shoot 100. Reliability 255 and load 1 and 2 is 1,500. We have to go inside BGP 2000 and we distribute ERGRP 5000. Okay, done. Do show RP root ERGRP 49,101. If we do show RP root season. Okay, this is non via GRP, and it's distributing via GRP advertised by 2000 BGP. This is via GRP and BGP. Okay. Let's go. This is down. This one, this PE. Okay, for this PE, I have to have VIF on the BGP section. Let's see if we have any. This is our PE. Show down pipe section rotate BGP. Okay, I have address family VPNv4, but I don't have VIF for this one. Show VIF. Config T. Rotate BGP this one. Add this family. Add this family. IPv4 VIF. No. Okay, this is address family. Come on, let's see what ERGRP. Okay, this should be ERGRP 6000. Do shut down pipe section rotate ERGRP. Yes, this is 6000. Redistribute ERGRP 6000. This is VIF. Link is VIF. And I have to redistribute BGP under this address family, under this VIF. on the we have to this is BGP on the this VRF. Okay, let's see what the this family, this one. Oops. Topology base. What is the metric? Do show IP pro. Actually, do show IP interface brief. Do show interface. This is this one. To distribute BGP. What was the BGP? Six five. Metric is bandwidth. Delay tens of microseconds. This is one. Reliability 255. Load 1. And MTU is this one. This is MTU. Okay, we have to add hood target here on the VRF. To show VRF, to show down pipe section VRF definition. Okay, we have definition renew here. We have RD, and we have to with target export. $200 only 200 export and import should be the same. 200 should not see 100. Okay, this is this one. To show RP root IGRP. Oh, this is VRF. To show RP root VRF. For example, 666. Okay, known via EIGRP, advertiser via BGP, and the distributor via EIGRP and BGP. Okay. This is this one down. We have to conquer this PE and this PE. Okay, let's go. $15. Okay, we have two different VRF, one for Houston and the other one for site red. One is to target 200, the other one is target 100. Let's go 15. Show VRF. We have two kinds of VRF. Okay, show VRF. Show part 5 section VRF definition config T. This is Z and Houston. We target for Houston. We have to add 200. We target import 200 to show. Okay, I'm wanted. We target export 100 and we target import 100. This is because red and Houston should not see each other. Okay, let's see configure BGP and redistribute. Okay, we have to have VRF IPv4 VRF under BGP configuration for red and Houston. Run 5 section rotate BGP. Okay, we have for Houston. I have to add for red. This is red. This link is BGP. I don't have to redistribute BGP. Only I have to redistribute this OSPF process here and here. I have to only add redistribute OSPF inside BGP and vice versa. BGP inside OSPF. Okay, one important part is that we have two different OSPF process, one for core, this is core, we have another process ID, OSPF process ID for this VRF. Let's say for this 52 short IP protocol pipe include OSPF. This is for OSPF 15 for core. I should not redistribute BGP on this OSPF process. I should redistribute BGP on the OSPF VRF process ID. Okay, let's see. Do show IP protocol pipe include protocol VRF that pipe include include OSPF. Okay, this is I have to distribute BGP on this OSPF process ID. Do shut down pipe section rotate OSPF. We distribute BGP six five six 65600. Oops, subnets and do shut down pipe section rotate BGP. I have to go this rotate and go to this is address one we have read and you distribute OSPF. What was that? This one. Okay, this is done. Only 16 left. Let's convert this one. 16. Okay. We have blue for who target 200 and site red for who target 100. Show VRF blue and red. Show down pipe section VRF definition. We have definition config T. This is blue. We have 200. We target export 200. Oh, 200. A target import 200 exit and ref definition that root target export 100 100 and root target import 100 100. Okay, I have to have IPv4 VRF for this and this on the BGP section. Okay, let's verify this. Do shutdown pipe section dot BGP. Okay, at this family of people VRF. Okay, rotate BGP. At this family IPv4. Blue. And that this family IPv4 VRF. Dead. And the BGP address family for each VRF. I have to have BGP IPv4 address family for each VRF on the BGP section. Okay, then I have to redistribute. This is EIGRP inside BGP inside VRF and redistribute to CIGRP inside BGP VRF. What is this? And redistribute this inside VRF. This is the same here. Okay, let's configure VRF. Distribute. Let's do EIGRP first. It is EIGRP 7000. Do share IP Pro. This is EIGRP. Do shutdown pipe section with EIGRP. This is VRF. This link is VRF. Okay. Let's go and redistribute BGP first. I have to go to project base. What is the link? Link for BGP is 160. To show IP interface brief. To show interface. Okay. BGP 65600 Matic bandwidth is this one. The delay is tens of microseconds. This one 100. Reliability 255 reliable. Load this one, and MTU is this one. And do share on pipe section rotate BGP. On the address family VIF blue. BGP 6566. Address family VIF blue. Redistribute BGP. XVIGP. YBS 7000. Let's see what OSPF process ID we have here. Do share on pipe section .ospf. This is I can verify by SHA-IP protocol either. SHA-IP protocol, VIF red pipe include OSPF. This is the same. Okay, let's see. We go to the VIF red. We distribute BGP 6566 subnets and to show on pipe section rotate BGP. I have to go this red rotate BGP 656 address family distribute OSPF this one. Okay, done. Push down section left it. Add the .t on. Okay, done. I have configured this RPs. Okay, let's see what problem we will face. As I said before, because this is DMVPN Phase 2, we don't have MPLS label between spokes, and this will cause reachability problems here. As we one option is change the VPN design to Phase 1. But we have another options here. Okay, let's see what the problem here. What is really going on? Okay, there is a critical issue dealing with the quantum plan MPLS forwarding between the site targeting DMVPN network. Quantum plan appear to be optional at this point, but due to the DMVPN Phase 2 nature of preserving the underlying IGP next hubs, DMVPN Phase 2 is preserving IGP next hubs, and MPLS forwarding is broken, and some sites do not have reachability. This is because we have Phase 2 and next hub is preserving. This is the issue. Okay, to fix the issue, 6 and 7 must set themselves as the next hub for VPNv4 routes, reflecting between peers. Okay, normally BGP route reflector cannot modify the attribute of reflector routes, including changing the next hub itself. Next hub step. Okay, as we know what is next hub. Let's see next hub here. Okay, default. If we have here IBGP here, this is eBGP. The normal. This is IBGP. If we advertise the next hub, the IBGP will not change. If for example, if we have 1.1.1.1 and advertise to IBGP, CBGP, IBGP will not change the next hub. This will set the IBGP next hub and advertise it. For this reason, we use next hub self command to fix this issue. Okay. Where is this? Oh, okay. We have next hub self. Okay, using next hub self on a route map, change the next hub will only take effect for eBGP routes, not for IBGP VPNv4. The default next hub self is only for eBGP routes, not IBGPs. But we have one more, another command, new command of the added in this version. The new command is all, which allows with reflectors to change the next hub for both eBGP and IBGP routes. Okay, this will fix the problem. Okay, let's see. 6 and 7 next hub must set next hub to themselves, and for this reason I have to use next hub self all. That will change both eBGP and IBGP routes. It is Okay, this is the this section will say the details of the problem. Okay, let's see what is going on in details. 16 VPN from site 1. What is 16 from site 1? Let's see. The root we had with the router 15 and was reflected by 6 and 7. Okay, let's see. This is 16. Okay, this is this one and this one. This is VPNv4 from site 1, site 1, and followed by 6 and 7. This is true. And select the good reflected path as the best path, and 1. This is going to verify. Okay, we can verify this. This is the problem in details. Okay, this is we can verify the control plane of this and sharp with this one. Okay, this is empty label field and data plan first when transit sent to this prefix already. Okay, let's verify if data plan is failing. Okay, data plan is failing. This is because MPLS label, because there are no transit label bound to this fact. Okay, we can verify this. Okay, because 15 and 16 only have LDP session with 6 and 7, not between themselves. Okay, this is, as I said before, this is due to MPLS DMVPN Phase 2. DMVPN Phase 2, we don't have label between spokes. This is the problem. And we can see this in detail for these commands. Okay. Sharpie LDP bindings and for one table. Okay, we have see this. Okay, if we see this showing forwarding, okay, this is LDP neighbor. Okay, showing on the showing page LDP neighbor command. This is neighbor command. We don't have okay, let's show RP safe. We are afraid 150 122 in details. Okay. Okay, as 16 sees that this is the next hop for 555. You can see via label 30. This is the next hop for 555 in the routing table. However, it doesn't find the same next hop address being advertised by any of the LDPPs. We can verify this by this command. If we type this command, this is not on the address bound to PIDnet. This next hop is not on this. This is the reason. This has no label. Details, we have no label, and we can see this on that section. Okay, we have as I said, we have this is the same for R15. Okay, let's verify R15. Where is 15? Okay, this is not half. Loopbacks. Okay, 6 loopback. Show interface brief. Okay. Okay. We have three options. Make change the origin except to achieve current state. Not possible due to DMV task restriction, and establish a DB session. We can establish LDP session between spokes, or we can make the option the VPN next hop, upload next hop, save all on the other. Okay, let's fix by uploading next hop, save all. To fix this issue, I have to set next hop save on the 6 and 7. Ensure run pipe section dot BGP this is template policy config t rotate BGP template p policy IR policy this is VPNv4 policy. Next up, save all. Save. This will enable for both and 7 should run pipe section dot BGP template people for policy. Next hop save. Okay, this will set next hop to itself. Hops will set next hops to themselves. Okay, let's verify. Okay, now we have the second loop back. And input the label. Used to we had 6666. Let's wait for this. BGP. We have label and the tests are safe. Okay, next up is tunnel 2 and we have label. And show MPLS forwarding table for this one. We pop the label. Okay, sharp root, let's wait for this. Sharp root OSPF. Sixteen. Just 13. 13. Show blue pipe section hotel BGP 1616 showdown pipe section hotel OSPF. Okay, it's BGP 656 is subnet. Okay, let's verify this. 192. Source. Okay, this is working. This let's verify other links. This is CLS. Ping interface. Okay, we have connectivity. Okay, done. Okay, I hope you have enjoyed this video.